What math do most people struggle with? You're probably thinking measurement, proportion, fractions, graphing, data analysis with statistics, algebra. There's a lot of things. So I'm Dr. Jonathan Brenderfer from the Developing Mathematical Thinking Institute, and today we are going to be talking about number lines. They are so important, and we're going to be talking about the reasons. It seems real simple, but it's not happening in classrooms, K-8, and it needs to be. We're going to talk about a lot of different details about how it's so important, so effective at constructing ideas to get kids to be better at all those math concepts. So the title of this DMT Insight is Why Letting Kids Create Number Lines Builds Stronger Math Minds. So first, let's talk about the cognitive reasons why this is so important. So first thing is proportional reasoning. So while I was teaching algebra, one of the things is that we noted that most kids don't have really good proportional reasoning, being able to see magnitude and increase that size by some amount, this kind of linear function. So one simple example is just asking your kids, okay, construct a number line, just draw a number line, 0 to 100, and just place where 34 is. See if they can do it. This I have found going into 3rd, 4th, 5th, 6th, 7th, and 8th grade classrooms, students really struggle with that. That's really important idea is to have proportional reasoning, because that's a gateway into all the other higher levels of mathematics. Second thing is this ability to iterate and partition. Really important idea is being able to take, even if you have 0 to 10, and can we partition that into 10 equivalent units? Try that with your kids. Have them do that too. Or if we just have, we'll say a unit of 2, that's the magnitude here on the number line, and now iterate it, copy it again, 4, 6, 8. Can they do it so it's the same amount every single time? Those are really important skills, and they should be starting in kindergarten and then building on that every single year. And so on that activity I was just talking about, I want them to draw the number line, what we'll call an open number line. They're putting where 0 is, and they're going to iterate each tick mark. Now, if they're struggling, then we're going to go backwards and actually create, like grab 2 cubes, and they can take those 2 cubes, draw a little line, and then iterate it, draw a line, so then they can have the 2, 4, 6, 8 proportionally. But we really want to see if they actually have the skill, given nothing else except for a number line, just the line by itself. Another really important idea with the number line is it helps map cognitively number to space, which is so critical. Spatial reasoning, one of the key indicators. You can see one of our other DMT insights on why spatial reasoning is so critical, because it leads to all this amazing mathematics, anything that mathematics is related to, engineering type computer science. So one of the activities to try is having students think about a unit of 1 and a unit of 10. So now you're going to construct 32 and 23. Both numbers have the same digits. How are they proportionally? Which one's bigger and why? So getting them to think through that 3, on the number line, we have 3 10s and 2 1s versus 2 10s and 3 1s. So then they get that proportional. So that starts helping them build a number line in their head so that they're better at understanding number, estimation, proportion, all the things. So another example with unit iteration and partitioning is thinking about, could you just show me on a number line where 1/4 is and 5/4? And so give them nothing else and see how they have that 1/4, and can they iterate out 2/4, 3/4, 4/4, and 5/4, and do that so all the intervals are equal. Okay, so now let's talk about, so the number line is so critical in a number of different mathematical topics. So the first one is just the idea of measurement. Measurement, again, is one of these structural ideas that are so critical that we need to include more measurement ideas always in our K-8 curriculum. It's because one of the things it does is it forces us to look at where is 0, and then we're going to be iterating units, we're going to be partitioning units. And partitioning means we're going to decompose them, but they are going to be the same size subunits. So with measurement, we're thinking about all these key ideas of 0, iterate, partition, what is the unit, we're scaling, proportion, has all these really incredible benefits. That leads into things like fractions and decimals. Fractions and decimals. So the idea of a fraction itself is 0 to 1, and we're going to partition that 1. So say it has 5 different subunits. Each of those is going to be considered a fifth because there's 5 units from 0 to 1. That's a really critical idea. And that's also related to decimals then. So decimals are related to fractions, special fractions, because they are partitioned from 0 to 1 into 10 units, and then each 10th unit is partitioned into 10 more. So one of the things I was doing with 5th graders last week is I had them build a number line from 0 to 2. So we put the tick mark 0, we put the tick mark 2, and I said, okay, first activity, where's 1? And you would think, I was thinking, maybe this would be it's an easy activity. No. Over half the students put from 0 to 2, they put 1 right next to 0, because that's 1 goes right next to 0. Not the idea of magnitude that 1 is the distance. That's one of those measurement ideas too, is a distance from 0 to 1 and 1 to 2 is the same. So we talked about that first. And the next part, more difficult, now we're going to partition between 0 and 1 and 1 and 2 10 times, because we're going to be talking about decimals. So just the idea of being able to partition. So one of the things we did was 0 to 1, let's go in half, there's 5, and then we're going to do 4 partitions to get to that 5th partition, 4 more here, and to get to 1, which is the 5th partition, so then you get the 10. And then we talk about that unit of 10th and its relationship to 1. And then we do that again. That was difficult, so it's really important to have them construct the number lines themselves so they're actually attending to these really critical ideas of 0 and the different intervals and equal distances and magnitude. So another one is data analysis. So data analysis is around us all the time, and a lot of times we kind of put that on the side of the curriculum and we just don't address as much. But they're incredible contexts to get kids to think about these ideas. So one of them would be 3rd grade. We're going to do handspan. So we're going to measure handspan to the nearest centimeter. So what we do is we take our hand and we measure from the tip of the thumb to the tip of our little finger here, and then we're going to look and estimate it is close to 12 centimeters. We're going to collect that data. So we collect the data for the class, and then one of the things we're going to do is we're putting it on a number line, and then the idea is, well, do we need to start at 0? We don't. So if we think about what is the shortest handspan for our 3rd graders, maybe it's 6 centimeters. Okay, and it goes to maybe 14. So now our scale, so the kids are doing this, we could start at 6 and go to whatever number we want. You can do maybe 1 less and 1 more, but this is the idea of getting them to start understanding the idea of scale, and do we always need to start at 0? Another for data would be doing categories where we might collect, walk around and do colors of shoes. How many white, how many black, how many blue? And then as they build, there might be 8 blue, there's 12 white, there's 2 red. So now all of a sudden they're getting, as they're doing the scale up, they're getting proportion again and magnitude of what is the difference between these different numbers. So again, a great context to be helping build on this idea of the number line. So then the 4th topic I want to hit is algebra. So graphing is such a critical idea in algebra. And so one of the things I noticed as an algebra teacher is if we just are given a bunch of data, and so it's we're measuring the standing long jump. And so we're doing that to the nearest inch. And if I just give these random numbers, what kids do is they start just putting the numbers on these different intervals, even if they don't make any sense. And the distance is not the same. So you could go from 28 to 32 to 33 to 40, and they're all the same distance. And so again, it forces this really odd linear graph, which makes no sense. So the idea again is we're missing the idea of constructing number lines. So then by the time they get algebra, they're not interpreting graphs correctly and they're not creating graphs correctly. Major issue. So I just want to sum up these 4 topics. We talked about it with the number line, having them constructed, help build ideas of measurement, which is everywhere. It helps them build ideas of fractions and decimals, which is again really difficult if you don't have those number lines in your head. And graphing with data analysis, and then graphing when we hit algebra. Key topics. So some recommendations that we should be working on. Okay, let's have kids have open number lines all the time. Have them construct them. And this should be happening in every grade level throughout the entire year, every time. And an open number line means there's no tick marks on it. It's just a line, and they have to introduce what those tick marks are. Do we need 0, not need 0? What are the distances? Are we skip counting? So that's recommendation number 1. 2, we really want to embed the structural language. Again, we have a DMT Insight if you want to hear more about this and why it's so critical. But 6 words that come up a lot, especially in this topic. Key is, what is the unit? What are the subunits? Are we iterating? Are we partitioning? Do we understand the relationship of equal amounts? And then we also, I haven't talked about this as much, but decomposing and composing. And then actually including problems like this on formative assessments. It's really critical. So when you have an assessment, have them actually be building number lines and introducing it. For fractions, one of the biggest correlations is kids being able to locate numbers, fractions on a number line correctly. That is correlated to success in adding, subtracting, multiplying, and dividing fractions. So that's a good place to start, especially if you're teaching 3rd, 4th, 5th, and 6th grade with fractions, because if kids can't do that, we may need to take a step back. And then just using different real-life context with measurement ideas, geometry, data analysis are so critical. So include those all the time as different contexts and story problems in your work. And they're also engaging with each other. Students can look at each other's work. They might struggle. We talked about another DMT Insight on mistakes and misconceptions. It's like, oh, what is happening here? So great interaction and getting kids to really understand these ideas. So stop giving them the number line, make them build it. So if you like this DMT Insight, please follow us. Please share this with other teachers and parents where you think that they would really be able to use this information. And check out our website, dmtinstitute.com. We have lots of resources, and we also, our main area is doing professional development. We'll come out to your school and do workshops. We'll even do Zooms with your PLC. You can set up some professional learning community time, and we'll come in and actually help explain some of these ideas and talk to teachers why they're so important. Sometimes that just gets missed. So please contact us, and please like us and follow us.